Okay, so let us start it. Okay. Yes, so you have seen the degrees of freedom of kinematic pair. Okay, then formula also. Now you can try solving few examples. Like let us calculate the degrees of freedom in each of these case. So first is 3-bar mechanism. Okay. So what is our formula? Formula is 3 times L minus 1 minus 2J minus H. Okay. So here first thing is that in all these cases there is no H joint. H joint is the higher joint with 2 degrees of freedom. Here whatever joint is there, it is only turning joint, that the links can only turn about that joint. Okay, they will not have the movement about that joint like linear motion. So H, you can, in each of these cases you can consider H is equal to 0. You have to now just calculate 3 in bracket L minus 1 minus 2J. You need to know how number of links L, then number of joints with single degree of freedom. So every joint is here single degree of freedom. So calculate then for first. What is the answer for 3-bar mechanism? How many links are there? Yes. There are, how many links are there? 3 links. 3-bar mechanism में 3 links are there.
Yes, sir.
3 links.
Okay. And how many joints are there? 1, 2, 3.
3.
3. So what is the degrees of freedom for first case?
3 here minus 0. Minus
0 रहेगा sir.
0. Yes, correct. Okay, because I already said H is 0. So it is coming as degrees of freedom is coming as 0. Okay, so it is a structure. Next, for 4-bar mechanism, you calculate degrees of freedom.
3
1. Correct. Okay, फार्मूला देख लो. डिग्रीज ऑफ फ्रीडम का फार्मूला क्या है? 3. Okay, L minus 1. L is number of links minus 2J. ठीक है, it is your degrees of freedom. In 4-bar mechanism, there are 4 links and 4 joints. So your degrees of freedom is coming as 1. 5-bar chain, कितना है degrees of freedom?
2.
कितना आ रहा है?
So 2
And 2
2 आ रहा है, राइट? ओके, अब इसका देखते हैं डी का.
सेम रहेगा सर 2.
कितना है?
फोर है सर.
4.
यस सर. जॉइंट्स 4 है.
यहाँ पे देखो, यहाँ पे एक. यस, एनी अदर आंसर? Okay, see now here there is a little twist here. Okay, so number of links you can easily identify that there are 5 links. 1, 2, 3, 4, 5. Okay, now counting of joints. So you can see that here at point D and point P, there is binary joint, right? Binary joint. Okay, so already we count it as one joint. So here you have one joint, and at point B also one joint. Two links are connected. Okay, but at point A as well as at point C. Okay, at point A you can see there are three links connected: link 4, 5, and link 1. Okay, so at connection where three links are connected, we consider there as two joints, and in that joint is called as ternary joint, if you remember the last lecture. So at point A, actually there are two binary joints here, two J. Similarly, point C is also a ternary joint. So we consider a ternary joint to be equivalent to two binary joint. Okay, uh, as per our last lecture. Okay, so here number of joints J is equal to 6. Here J is equal to 6. Then you calculate the degrees of freedom. 0, right? Because this particular arrangement will not allow any link to move, even if link AB is fixed. Okay, but not link AD will move, even CD, AC, and even BC cannot move. Degrees of freedom is 0. Okay, then you calculate for the diagram E, 6 bar mechanism or 6 bar arrangement you can say instead of mechanism. मैकेनिज्म में तो मोशन होता है, तो इसको मैकेनिज्म जब तक प्रूव नहीं होता है कि मोशन होगा कि नहीं, मैकेनिज्म बोलना ठीक नहीं है. सो इट इज अ 6 बार अरेंजमेंट. कितना आ रहा है डिग्रीज ऑफ फ्रीडम? -1. ओके, बिकॉज हियर हर पॉइंट पे दो लिंक कनेक्टेड है, ए डी सी बी, तो हर एक पे डबल जॉइंटेड 2J. So your degrees of freedom coming as -1, right? So it is also not a mechanism. It is also a structure. Okay, which is having one redundant member, means एक member extra दिया है, and that extra member will add the strength in that. If you want to put more load on it, okay, it will become more rigid. Okay, so this is the example how we calculate the degrees of freedom. Okay, here we have seen this example where there is no any joint with 2 degrees of freedom, means no higher pair, that is H is equal to 0. Okay, now let us see. Okay, see what are the different meanings which are coming out. For A it is 0, so it forms the structure. 1 means single input motion is required. 2, two input motion parameters are required to control the complete mechanism. 0 again D का आंसर था. E -1 redundant constraints means additional दिया है, and such a structure cannot be solved using just the equation of statics. Okay, some different approach is required to solve the numericals of that, means to find out the stress, its carrying capacity, other things. Okay, now these are again the examples. okay, to calculate the degrees of freedom. But here we have considered higher pairs also, okay, or 2 degree of freedom joints. So you can see the joint between 2 and 3. Okay, what will happen here? That link can turn about this point. यहाँ पे 2 और 3 में कैसा रिलेशन है कि link 2 can also turn as well as it can slide. It can slide because there is no any pin connection. It just link 2 is resting on the surface of link 3 in figure A. So we will assume that there is one higher joint. The joint between 2 and 3 is H, not J. Okay, J is for a joint with 2 degrees of freedom, and J we are denoting as the joint with single degree of freedom. Okay, so in this case, you calculate what is the degrees of freedom. Now you will use the complete formula 3L minus 1 minus 2J minus H. Similarly here, see, similarly here, the joint between 1 and 4, the joint between 1 and 4, okay. So this wheel is just resting on the surface of 1, and there are chances that if there is not sufficient friction, then this roller, this wheel, it can also slip on the surface, right? So we will consider that the joint which is formed between link 1 and link 4 is of the H type, H joint. Okay, so in this case, you tell me what are the degrees of freedom. For A, you tell me first.
One.
A के लिए 1 आया.
Yes, sir.
Others, please calculate and solve for second. Solve for second.
2 रहेगा.
Second B के लिए 2 आया, right? और 1. देखो लिंक पहले केस में नंबर ऑफ लिंक्स कितना है 1 2 3 3 लिंक्स. फिर जो जे जॉइंट्स होते हैं तो वो कितने 1 एंड 3 में यहाँ पिन कनेक्शन है, तो 3 जो है वो सिर्फ रोटेट हो सकता है, टर्न हो सकता है. तो यहाँ पे जे जॉइंट आएगा, यहाँ पे जे जॉइंट, यहाँ पे एच जॉइंट आएगा. तो जे जॉइंट हमारे पास 2 है और एच जॉइंट 1 है. तो फिर आप कैलकुलेट कर सकते हो. यहाँ पे लिंक 4 है और जे जॉइंट देखो यहाँ पे 1 और 2 के बीच में जे जॉइंट आएगा 1, 2 और 3 के बीच में जे, 3 और 4 के बीच में भी जे जॉइंट आएगा क्योंकि ये व्हील तो वहां पे टर्न ही होना है, उसको पिन पिन कनेक्शन यहाँ पे. तो 3 जे जॉइंट हो गए और यहाँ पे 1 और 4 के बीच में ये यहाँ पे रेस्ट हो रहा है सिर्फ. यहाँ पे एच जॉइंट आएगा, एच 1 जॉइंट हो गया. तो डूइंग calculations, you will find the answers are for first case degrees of freedom is 1 and for second case degrees of freedom is 2. Okay, uh, getting this, how we are doing the calculations and how to first it is very important that identify that which kind of joint is there. Okay, and if in absence of data, okay, you will assume that the the joint between 2 and 3 is a H type joint because it is not mentioned that sleeping does not happen. If it is mentioned that sleeping does not happen between 2 and 3, then you will again eat a joint with single degree of freedom, means it will also become J instead of H. Okay. Okay, then next, I'll also ask you to put your attendance in chat box. Have you put in the first lecture?
No, sir.
Put it now in chat box, your roll number.
Now we have
Yes, all of you please put. I see participants are 13, but in chat, let me see the chat. Chat in chat only 9 entries are there. All of you please put your attendance because sometimes it becomes very important. Okay. Then let us say briefly. Let us discuss the Grubler's criterion. Okay, for plane mechanism. So already we have come to Kurzbach equation to calculate the degrees of freedom. Okay, so what Grubler's did, okay, it obtained, you know, that in practical applications, okay, the mechanisms with single degrees of freedom are very useful. Okay, generally 2 degrees of freedom mechanism are not required. Okay, generally most of times. So what Grubler's did, it derived an equation in order to satisfy the condition of 1 degree of freedom of the mechanism. Okay, so what he did, he put the value of n 1 here. Okay, and he assumed that h, that is the joint with 2 degrees of freedom, is not there in the mechanism, which generally happens. So he put n is equal to 1 and h is equal to 0 in this equation. So the result came out like this equation got simplified like this: 3l minus 2j minus 4 is equal to 0. Now from this equation, it is called as Grubler's equation or Grubler's criteria. So from this equation one can know, see, here there is the digit 4. Okay, here there is j. So if j is 1, 2, 3, 4, or 5, whatever, so 2 into that number will be an even number, correct? Because it is multiplied by 2. Here also there is one even number constant 4. Okay, so in order that this condition is satisfied, okay, number of links should also be even in the mechanism. Okay, means a mechanism with single degree of freedom cannot have the odd number of links like 5 links, 7 links, 9 links, 3 links. No, if a mechanism is having odd number of links, then it may not be a completely constrained mechanism. It may not be a mechanism with single degree of freedom. Okay, so that is called as Grubler's condition or Grubler criterion. Understood it? Because here number of
Yes, sir.
links,
Yes.
yes, because here number of links is multiplied by the odd number. Odd number 3 is the odd number, and suppose if any 3 is multiplied with any odd number, okay, then what will happen, that this zero condition will not be met on the right hand side, and number of links are always the whole number. It will not happen that there are 3.5 links in the mechanism. No, there are 5.5 links in the mechanism. It will not happen. Okay, so that is the condition which is derived by the Grubler. It is very simple, okay, but it has few deductions. Okay, so for now, we will stop here. Let me see if I planned any other thing to for today. Okay, no, okay. So for now, we will stop here. Then tomorrow we will start with the invergence of mechanism. Again, I also searched for the query which was raised last lecture. Okay, but unfortunately I didn't get the answer so far. Even that in that book it is mentioned like that, that left hand side is equal to right hand side. So as per my knowledge, there are certain rules. Means this particular equation, okay, you cannot apply to each and every mechanism. There are certain restrictions, okay. So we have to just find out that thing, that uh, I have to refer some another book for that. Okay, it is in some other book. I will just find out it, and I will definitely come to that point. Okay, or in a while you
Okay,
can
sir.
also remind me for that. Okay, suppose I get a little off from that point. Okay, then you can also remind me for it. Okay, so if you have any other doubt, you can ask me. Okay, our strength is good. 12 people are there, so only 3 people are not there. Okay, I will find out who is not there. So only in chat, have you given the attendance or not? Yes. Okay. Okay. It was showing me the latest attendance count. Okay, which I have not seen. If you don't have any doubt, then you can leave. Otherwise, you can ask your doubts or get some information which you want to get.
Sir, the ball bearings also have 3 degrees of freedom.
Ball bearings has, you know, it has a roller in it. Okay,
Yes, sir.
and and why roller is used? Because it has very less friction. Okay, so
Yes, yes.
in a ball bearing, it is assumed that these balls will only roll, because rolling friction is quite less as compared to the sliding friction. Okay, so it is assumed in ball
Yes,
bearing
sir.
that they will only keep rolling. Okay, so we can say that they have the
Okay.
single degree of freedom, rolling pair.
Okay, sir.
Okay,
Okay, sir.
okay, okay, then take care.
Okay, sir. Thank you, sir.
Welcome. Ending the meeting.